This is a solid glass sphere. I will cut it here now. Now another lens, another solid sphere. And the person, what happened, will cut it here. Now you will construct, so there's a lens one, there's a lens one, lens two. I'll bring this. I'll construct a telescope. I'll come to this reflecting later on. This is one way of asking very good question for you. So what I do is like this part. I'll fix. This having more aperture, no? So what do you mean by aperture? And the focal length has not changed. Am I right? The focal length of both the lens is same, if not. You look at this aperture. This is what the aperture. So it be books. We don't have much discussion. They just said aperture. You look at this, the diameter, where the aperture is more. Here aperture is more. No, this having more aperture. Both are having same radius of curvature. The curvature is same for both. But instead of cutting here, if I cut it here often, I'll get more aperture. Now both are having same focal length. I'll use this in normal adjustment. Both the telescopes are, okay, telescope, okay, this one. There's a 1 and 2. I brought it here. Now, which will have more magnifying power in normal adjustment? Both will have same magnifying power. But this will have more resolution. Resolving power of 2 will be more than that of 1. Any reason for that? Because resolving power depends on what? Resolving power depends also on the diameter of the lens. I think you know d theta equal to 1.22 lambda by small d. So resolving power is equal to how much it is? What is the formula? D by 1.22 lambda. What is d? Diameter of objective lens. Okay, got this one. So now you can see from the diagram, the second lens is having more aperture, diameter or of objective lens or aperture. Diameter or aperture. I'll write it here. Okay, these are very dangerous questions can be asked. The student must have seen one's telescope, or else at least through diagrams you should have analyzed. So now, which will form a better image? I say better image. This will be a better image. Clarity will be very good. Resolution will be very good. Clearly, you can see things here. And there's a thing. Okay, now what is another thing is, so by increasing aperture, I'll increase. Then, moreover, if you increase aperture, what is one more thing? It will capture more light, then clarity of image will increase. But what we have seen is like, there'll be some loss of light, though it captures more, no, when light passes through the lens, it will be absorbed. Some intensity will decrease here. So, and moreover, to increase the resolving power, what is RP? Somebody is asking what is RP. Yeah? Okay, let me write. It's a resolving power. So to increase resolving power, what I should do? I should increase aperture. So constructing a lens, manufacturing a lens of diameter 2 meter, 3 meter, 10 meter, very difficult, and maintenance. More telescope, no, it's not a fixed. I should rotate, no. Such a heavy lens fixed to telescope and telescope rotating. We need machines. So these are the drawbacks what we are going to face. So therefore, I want to replace this objective by something. So what are the things? First, constructing astronomical telescopes of high resolving power. What is the biggest problem? The lens will be heavier. We need machines to rotate telescope. So to overcome that, the reflective telescopes are brought here. So what is the basically construction reflective? So usually reflective telescopes will use in normal mode. No? So let me